Hi guys, this is your next question from Cat 21, the first lot. Please pause the video and try it once and you can resume for the solution. So a circle of diameter 8 inches is inscribed in a triangle ABC where angle ABC is 90 degrees. If BC is 10 inches, then the area of the triangle in square inches is. Right. So there are multiple ways to answer this question. We'll look at all the methods one by one. So let's start with the most conventional approach. In this, what we have to do is you have to observe the center of circle. From this, I'll draw the radius here and I'll draw another radius here. Now observe that by tangent perpendicularity, this angle would be 90 degrees and so would be this angle as 90. So now I have a quadrilateral OPBQ. In this, exactly three angles are right angles. So naturally, the fourth angle is also a right angle. Some of the angles should be 360 degrees. So OPBQ is actually a rectangle and the rectangle also has adjacent sides equal. So OPBQ is actually a square. For this square, the side is nothing but the radius of the circle. The diameter of circle is 8. So the radius should be exactly half of that, should be 4. So OP and OQ are both equal to 4. Naturally, PB and BQ are also equal to 4 each. Now, BC, the entire length is given as 10 inches. From that, if I remove BQ, that is 4, I would get the length of QC as 10 minus 4, which is 6 inches, right? And now going further, I notice that from the point C, I have two tangents drawn to the circle, CQ and CR. So length of tangent segments from external point to circle are always equal. So if CQ is 6, CR would also be 6. In the same way, from the point B, I have two tangents to the circle, BP and BQ. So we can see BP and BQ are also equal. And the same logic I can apply for tangents AP and AR. From the point A, I have two tangents drawn to the circle, AP and AR. Let AP be equal to X, AR will also be equal to X. So now, the side AB of the triangle will be actually X plus 4. Similarly, the side BC is given in the question as 10. And the side AC, the hypotenuse, is actually X plus 6. And now you can use the Pythagoras theorem. AB square plus BC square would be equal to AC square. AB square is X plus 4 the whole square plus BC square is what? 10 square is AC square, that is X plus 6 the whole square. Now you could use the expansion of A plus B the whole square and open both the brackets here. A slightly better way would be is subtract X plus 4 the whole square from both sides. So the left hand side would simply have 10 square remaining. On the right hand side, you will have X plus 6 the whole square minus of X plus 4 the whole square. This is like A square minus B square. And A square minus B square is always A plus B into A minus B. So X plus 6 minus X minus 4. So this part simplifies to 2X plus 10. 10 square is 100 is equal to 2X plus 10 into, in this part, X gets cancelled out. 6 minus 4 is 2. So 100 is 2X plus 10 times 2, or 2 and 2 cancel. I get 2X plus 10, 50, or 2X is 40, or X is basically 20, right? So if X is 20, I know that AP will also be 20 and AB, the entire length will be 20 plus 4, 24. So I already knew BC in the question. I've also found AB in this question as 24. Now I can very easily find the area as half into product of the perpendicular sides. Half into 10 into 24. The answer required is 120. The area of the triangle in square inches, 120, right? So this is one way in which you can get the answer. Let's look at another way of getting the answer here. We know that for any triangle, the area is in radius into the semi-perimeter. And since this is a right angle triangle, the area will be same as half into product of the perpendicular sides. So now in radius we know is 4 in this particular question into semi-perimeter will be sum of sides divided by 2. So AB is x plus 4, BC is 10, and AC is x plus 6. All this divided by 2 is equal to half into product of perpendicular sides, x plus 4 into 10. So this is another way in which you can figure out x, and then the value of x you can substitute in any of these two expressions. You will get the area of the triangle. So solving further, 2 and 2 gets cancelled. I'll have 4 into, this would be 2x plus 20 is equal to, 2 has already been cancelled out here, 10 times x plus 4. So again, when you open this, you get 8x plus 80 is actually 10x plus 40, or 2x is 40. Thereby you get x as 20. Once you get x as 20, you can put it either in this expression or this one. You get the area again as 120. Okay, that's another way of getting the answer here. You equate the two areas, half into product of perpendicular sides and in radius into semi-perimeter. That's the other way out. So now let's look at the fastest way of getting the answer here. In our lecture series for geometry, we have studied the Pythagoras theorem, in which we have learned to derive Pythagorean triplets. And in that, we had basically seen a table. If you remember, guys, in the table, we had listed the Pythagorean triplets and their in radius values. So in this question, the diameter of circle inscribed in the triangle is 8 inches. So basically, the radius will be 4. This radius 4 is the in radius for this entire circle, right? The in radius is 4. And now in our table that we had discussed, we can check for a Pythagorean triplet having one side as 10, the perpendicular side is 10, and the in radius is 4. You'll very clearly observe this is our 10, 24, 26 Pythagorean triplet. So if you remember the table we had discussed in our course, you will instantly get the answer half into 10 into 24, and that is 120. Now, if you don't have the table, you can still get the answer here. By hit and trial, observe that the Pythagorean triplet is 10, 24, and 26. And you can verify the in radius being 4 by using the formula for the area. Area is half into product of perpendicular sides. This will be same as in radius r into semi-perimeter. So 10 plus 24 plus 26 upon 2. When you solve this, you will eventually get r is equal to 4 as given in the question. So yes, the Pythagorean triplet is 10, 24, 26. And thereby the area is 120. Although I recommend the way we are discussed in our course, please remember the table for Pythagorean triplets. It makes these questions very, very easy. And CAT has a history of asking questions based on our table. So that's how it is. The fastest way of getting the answer, area of the triangle required is 120.